Hey, hello there. So today I'm continuing looking at linked list related questions. So I got two questions today. The first one is 83, remove duplicates from sorted list. We have a sorted linked list, so the nodes inside this linked list, their values are in the ascending order. We need to delete all the duplicates such that each element appear only once. So since that the list is sorted, the duplications, the nodes with the same value are going to be adjacent to each other. So let's just say that we are currently looking at a particular node here. In order to remove the nodes that can potentially have duplicated value with this node that we are looking at, all we need to do is to check the next. If we just so happen to have the same value as our next, we're gonna just short that next connection. So instead of pointing to my original next, I'm gonna pointing to the next. So obviously we want to continue doing this until that if this is 1, we will continue doing this iteration until that the node that we're currently looking at is pointing to a node of different value, and that at that time we can advance to move forward. So since that now the traversal node pointing to the node 1 is different than the next, then we can actually safely move to move over there. So that's an iterative approach of solving this. Just checking the adjacent nodes. If the next is of the same value as our node, we're gonna short that connection. We do so until that our next is of a different value, then we can move forward. So it will be a linear time algorithm. We parse the linked list from the beginning towards the end, and it will be constant space. So this is the pretty straightforward iterative approach. So we start our traversal at the head node, and while we can still do this comparison, meaning that we have a next node that in the sequence we can potentially have duplicates. If we don't have any next node, then that means we pretty much done. What we need to do is to check the values between my value and the next node's value. So if my value is different than my next, that means there is no duplicate value. There is no node with the duplicated value as myself, so I can move forward. Otherwise, I would need to short my next. Where am I? So this is going to be the iterative approach. It's going to be linear in time and constant in space. The logic is pretty simple. So another way of solving this is to think about this question sort of like more. I'm gonna put it on here. Another way of solving this is to solve this recursively, which is going to be actually require more space complexity because we have to relay the task to our next. So the way to reason about that is if I'm currently looking at the node here, let's say that I'm at node 1. So I do find that myself is of the same value as my next. So what I'm going to do is to give myself up, and instead of calling this function delete duplicate as if that my next is actually the starting point of the linked list. So it will do so recursively, so that you will continue checking if my next has the same value as my next. My next is also going to be voluntarily give himself up. So until that we do find the node has a different value with the next, you will actually return its own value as if it's the head node for subsequence of the linked list that has no duplications. So if myself has and my next, the values are different, I'm gonna ask my next to do the same thing, to do the deduplication from himself, him or herself, and on. After he or her done the same job, I'm gonna actually connecting myself with him also, with my next. So that's the recursive relationship. So I'm just gonna note it down here. If node var equal to I'm just gonna use dot here. If this is the case, that means I want to give myself up. And I should return the function, recursive function of my next. If my value is different than my next value, I want my next. I want my next to do the same thing, and so that I can confidently connect myself with this next, because I know if he do the same job as I do, the subsequent nodes will contain no duplicates. So it might be the case that I'm node 1, and my next node has a node value 2. That's all I know, and that's all I care. If there are subsequent nodes that after my next that also has value 2, I don't really care. The who to give up himself, it's not my business. All I need to know is I want my subsequent linked list nodes to do the same thing, to do the deduplication, and after that I can connect myself to that node. So that's the recursive kind of a relationship. The base case is just for isolated node, I would just return myself. Single node, I would just call it a single termination node, terminal node, or null pointer. Return self. So that's the recursive logic there. The code is pretty similar actually to the iterative. Oh, I should just change the variable name to head. So the logic is laid out there. Oh, sorry, I'm messing up the variable names. So otherwise, I will actually connect myself to this duplication of my next. After that, I will return myself. Yeah, the return myself is done there. So yeah. So that's the recursive solution. It will be also linear time, but the call stack can go as deep as it has to go as deep as to the tail node, and then backtracking all the way back to the beginning of the linked list potentially. So that's linear in space and linear in time. Let's see if it works. Okay. Alright, so that's this question, simple question 83, remove duplicates from unsorted list, solved both in the iterative version to short the links iteratively and move forward, or solve this recursively. So that's two approach for this question. Alright,